Well, a very good morning to you. My name is Bryn Smith. I'm the commercial manager at High Speed Transfers, which is a Purus wind company. And today I'm going to be discussing and outlining the deployment and operations of CTVs that we are currently doing here in the North Sea and other sectors across the globe. To start with, I'd like to focus on the fleet itself that we're currently running here in northwestern Europe. The Diamond Fast Cruise Supplier 2710, as you can see here, was the first vessel design that we added to the fleet back in 2017. These four vessels are what have really set the precedent for the rest of our fleet expansion that is currently ongoing at the moment. The assets themselves are 26 packs, so they can carry 26 technicians to the offshore wind farms. As you can see, have that larger forward front deck area, which enables us to carry both 2 times 10-foot containers, as well as any additional equipment that the technicians may be using, depending on the work scopes that they're undertaking for the operations at the time. The vessels are crewed by 3-man crews per 12 hours, so it'd be 6-man crew for 24-hour operations, and our standard diesel assets that, as a result, were the first that joined the fleet. This is just a quick look at the general arrangement of the Diamond 2710. As you can see, there's that large forward clear deck area, as well as an offset wheelhouse, which enables the crew to be able to move from the stern to the bow of the vessel without having to move through the passenger saloon. This is actually something that was very useful during the COVID pandemic, enabling us to keep the crew and the passenger technicians separated so that they could remain in their bubbles when preparing for operations offshore. These GAs, as you can also see as well, show the accommodation that is available on the vessel. We currently don't use this accommodation for 24-hour operations offshore, but this accommodation will be used for 12-hour operations for the crew to sleep on while the vessel is in port. The second vessel type and design that was added to the fleet off the back of the lessons learned from the Diamond 2710 was the Chartwell 24H. Now, these vessels are slightly smaller in length at around about 24 meters rather than 27. But what we've done is we've worked with the naval architects on this vessel to incorporate a lot of the good elements from the 2710 onto this asset. Again, this one is 24 packs, so she can take 24 technicians out to the wind farms. As you can see, again, has the offset wheelhouse to enable the crew to be able to transit from the bow to the stern of the vessel without going through the passenger saloon. It also means that we have the ability to completely segregate both the crew and the passengers, as we did on the other vessels during the COVID pandemic. The difference with the Chartwell 24H is that the vessel is now the first in class that we have, which is a hybrid asset. Now, she runs on 185 kilowatt hour batteries, and what we've worked out with the crew and our partners, with the operators, OEMs, and tier 1 clients, is that actually the vessel can be utilized on a 12-hour operation and 24-hour operation, where we're only using the main engines for around about 50% of the time. Now, this is achieved by utilizing battery power to operate the vessel when it is in port. So while the vessel is alongside, while the vessel is transiting in port to pick up the passengers, and while the vessel is transiting out to the outer port limits, that is done exclusively on batteries. Once at outer port limits, the vessel will then spool up to full speed on the main engines to reach the site. During that time, we can actually recharge the batteries off the main engines using a power takeoff. So once in sight and the technicians are dropped off, The vessel will go back onto batteries and will idle in the field in batteries, again, burning no diesel. We will then do the opposite and come and pick the technicians up, steam back into back into the port where the batteries will be charged again off the power takeoff, and then basically from the outer port limits, the vessel will then go onto batteries again overnight and prior the next morning until reaching outer port limits again. This actually is something that operates and offers demonstrable savings for the client, both on obviously the fuel as a financial saving, but also on the NOx and SOx emissions, as everybody looks to be reducing the emissions on their spreads across the board for the offshore industry. This is just a quick look at the general arrangement. As I said, very similar to the Damen 2710 from a functionality perspective. The only difference is that because we have the batteries now on the main deck, the accommodation for 12-hour operations in these vessels is in the hulls and can be seen there in the forward hulls. But again, that is only accommodation that is used during 12-hour operations. And while the vessel is in port, and the crew would utilize it then. This is just a quick overview and case study piece for the Chartwell 24 HST Ella, which was the first of the hybrids that we delivered into the market. This just outlines the comparison or direct comparison with a conventional diesel vessel. What can be seen here is the deltas at the end marked in green there show that there is around about a 21% saving on fuel, CO2 and NOx and SOx emissions for the operation of the vessel on a 12-hour basis. As you can see, there are some assumptions that have been made at the bottom there, but this is live data that was taken from operations at East Anglia 1 while we were working with Iberdrola back in 2021. Subsequently, we have also had the vessel on 24-hour operations with Louis Dreyfus in France, and we have seen actually slightly improved numbers on this basis. But this is definitely something that offers a demonstrable saving to the client, but is also a stepping stone for us as HST to be able to show to the market that our aspirations are to continually develop the vessels and to offer emission-reduced operations to our end customers. This is just further highlighting the environmental and operational efficiency that we do receive from the hybrids, and basically that the hybrids are our kind of learning curve. One of the key elements to review here is obviously the fuel saved there at 30%. That's slightly different to what we've just seen on the previous slide. These figures are based on the Rentel wind farm from Otary in winter 2021, which was the next project we did after EA1. It was a slightly smaller sample, and also there were some 24-hour operations in there. So we were able to achieve a slightly larger fuel delta at 30%. One of the key ones to look at here, though, is the engine hours reduction. What that means is the engine hours reduction is obviously good from a fuel and emissions perspective, but actually it's great for the customer from a maintenance perspective. If we are utilizing the main engines 41% to 50% less, that then means that our engine hour operations from a maintenance perspective are extended. So the 5,000 hour survey, 10,000 hour survey is the distances between those surveys is longer. What it also means is the engines on board these vessels operate best when they're working at high revolution. So essentially in the top kind of 85 to 90 percentile revs on the engines. When they don't work well is when they're working at low speeds, for example, in the ports, when they may be transiting at around anywhere between kind of 5 to 7 knots. That's when you start to get the buildup of residue and carbon residue within the engines. And that's when you would need to be checking things like the injectors and the other elements. So from a maintenance perspective, the hybrid operations actually also offer more redundancy for the client and actually reduce time performing scheduled maintenance and as a result, increasing the uptime for the customer. This is just a quick look at the new builds that we have coming to the fleet, which are going to be further building on the lessons that we've learned with regards to the Damen 2710 operations and the Chartwell 24 hybrids. The first of these are 4 StratCat 27 battery hybrids that will be coming from Singapore, the first 2 of which we're expecting to arrive back into the UK within May, so very shortly. These assets will be battery hybrid IMO Tier 2 with a view to be upgrading them to IMO Tier 3 to further reduce the NOx and SOx emissions and to also obviously be in line with international regulations. These vessels, again, as you can see, it's a very similar design with that large forward deck, the offset wheelhouse and pack saloon, and with a large 24 packs layout internally. The second set are the Damen 2710 hybrids. So on the success of the 2710, the shipyard have now put forward a hybrid design. We have actually 3 of these vessels and a potential 4 additionals also on the blocks at the moment, which are being built in Turkey. These are slightly different to the StratCats. These are battery hybrid IMO Tier 3, so they are already fitted with the IMO Tier 3 exhaust and scrubber system, which I'll come on to slightly later. The vessels are expected to deliver the same functionality that we've had for the 2710s, but with the Chartwell 24s hybrid increase, and obviously that reduction on engine hours, which hopefully can only be beneficial for the client. The new vessels and new technology section, we are also in dialogue with Damen on what we believe to be the next generation CTV, which is a 3210. So this is a 32-meter asset, which we are looking at for operations with the SOVs that we have within the group from Purus, which I'll come on to a little bit later. What we believe we can offer with the 32-meter is obviously the battery hybrid element. We believe that these vessels can be made methanol ready as well, so that we are looking already into this future fuel element. What the methanol ready piece will mean is the hardening of the fuel systems. So these would have steel-lined fuel tanks and basically hardened fuel management systems. Damen are currently in an execution phase at the moment with Caterpillar, as well as several other engine manufacturers, to see how methanol will affect the engines and to see, obviously, if this means that the warranty periods can still be maintained in the standard format that they're putting forward at the moment. These vessels will be utilizing a slightly different propulsion system to the other designs that we have. The current 2710s that we have in the market, they're using FPP, direct drive, which is fixed pitch propeller. The Chartwell 24s, we've had real success with CPP, which is controlled pitch propeller, which means that we can actually adjust the angle of attack on the propellers themselves, depending on what the vessel's doing. So whether it's going at high speed or whether it's pushing on. And obviously at push on, there's more torque is required to basically create the forces to generate the friction on the boat landing with the fender. This system will be utilizing quad Volvo IPS. This hopefully will give the vessel even further maneuverability, enabling her to operate in higher sea states as well as at higher speeds. The other element that we've put forward on here is a 24-hour crew accommodation piece. Because it's a larger asset, we do believe potentially that the crew can live on here on 24-hour operations, thus meaning that for 24-hour operations, we're not having to utilize any berths on the SOV if we're working in tandem with an SOV offshore. That, again, is going to increase the uptime, especially during construction and commissioning for the operators, as they sprint essentially to get the construction done on the wind farm, because only once the wind farm's up and running and commissioned can it actually begin to earn revenue for the owners and the operators. Obviously, the other element that is fairly self-explanatory with this vessel, because it's 32 meters, not 27, we will have increased cargo capacity as well. This means that the 3210 could potentially also be used as a supply asset So this would keep the SOV offshore, or the CSOV offshore, utilizing this vessel to interface with the shore and bring things like victualling, supplies, any mechanical equipment required, as well as potentially performing the crew changes. There is dialogue at the moment about potentially using helicopters for the crew changes. But again, I think this 3210 could act as a real workhorse to keep the CSOV offshore for longer. Just a quick overview of where we feel as HST the benefits between 24 packs and 12 pack CTVs. At the moment, we only have two 12 pack CTVs in the fleet, which were bought as second-hand assets to be placed onto long-term contracts, which we renovated the assets and then placed them into long-term contracts. Our outlook and mentality is that we will only probably be building 24 to 26 packs vessels going forward, which is what the rest of the fleet is. The reason we believe this are for these items here. You have the increased transfer capabilities at 1.75 meter HS plus. Again, what that does is increases the uptime and operability for your client. And by doing that, you become a favorable operator. The more transfer windows you can offer utilizing your vessels, the more turbine time the end client is able to achieve. The additional packs is obviously self-explanatory. If you can take 24, not 12, you will have more guys working offshore at any one time, and as a result, you should have a higher functionality and a higher uptime that, again, it can be offered to the client. The larger deck space for secondary operations. This is cargo carriage, but it's also things like ROV and drone launch and recovery operations. So once the passengers and the technicians have been dropped off, the deck space could potentially be used to undertake these additional operations and further add value to your customer's supply chain within the wind farm. Longer endurance. So we have a range at the moment. The original Diamond 2710s can take about 16,000 liters of fuel, MGO, whereas the hybrid Strat Cats can actually take up to 30,000. So what that means is we can actually have increased endurance offshore while working 24-hour operations in, say, construction and commissioning. Again, where it's that sprint to get the wind farm up and running. And what that then does is basically increases the vessel's functionality to work with the CSOV or SOV offshore. The potential crew accommodation is the piece that I've already mentioned for the Diamond 3210s, but again, it's trying to keep the vessels offshore as long as possible so that there is as much work being done in the wind farm, especially during weather windows that may be favorable but potentially quite short. And then the last is possibly one of the most important, is the increased internal space for equipment and the PAC's operating areas. The PACs and the technicians are, for us as the vessel operator, they are where our company meets the client, and the PACs being happy and enjoying the experience of utilizing our vessels offshore is a very important part of what we do. And it's very important because that gets fed back to the contracting teams and fed back to the shore-based teams and VMC, which then gets fed back to us. And this is how we retain these relationships with these vessel operators. So that's why we would say that we believe that the 24 packs operation for us is better than building the 12 packs vessels. This is just a quick look at the current CTV fleet overview. As you can see, all of these vessels are 24 packs assets. One of the key elements here is, if you look at the bottom, is the fuel type, which is the MGO, HVO, methanol, and the majority of these assets will also be battery hybrid. This is very much at the core of what HST is all about, as well as our parent company, Purus Wind, which I can go on to in slightly more detail later. But that shows the aggressive stance that we're taking on the CTV market to build vessels, both here in Europe and also in Southeast Asia, potentially for markets such as South Korea, and that we're looking to do that in a sustainable and emission reduction manner. This is the CSOVs that we currently have within the fleet. The first there is the REM Energy. She's on long term with Siemens Gamesa, and that's operating at Global Tech 1 in Germany. The second two are the new VARD 419 designs. These assets are what we call proper CSOVs, which is construction, service and offshore vessel, service and operation vessel. As you can see there, they are fitted with walk-to-work gangways, helicopters, as well as daughter craft. What we would look to do is operate the larger CTVs in tandem with these vessels and deliver a continued spread to any customers that we have. The parent company of HST, Purus Marine, who I'll give a short overview on shortly, they actually have aspirations to build more of these vessels, and we will be probably making announcements on those shortly. But again, this is something we can look to offer in Asia Pac and the Far East market, where we are able to combine CTV and SOV for both construction, commissioning, and O&M phases of the wind park. And we are actually one of the only operators. I think there are two others or one other that can actually offer those services as it stands at the moment. This is just a quick overview of how we believe the CSOV and CTV operations can take place. As you can see there, the CSOV in the middle, potentially serving 3 wind farms, or a cluster, as we would call it here in the UK. There are plenty of operations where the operator, such as Iberdrola, Ørsted, or the OEM, Vestas, General Electric, etc., have a cluster of wind parks that they're involved with in one location. What we believe is the CSOV could sit in the middle, servicing on the scheduled maintenance or on the scheduled installation plan, with the CTVs then working around that vessel to maximize the uptime and to create as much working and turbine time as possible for the client, to ensure that their work scopes are getting undertaken and executed as quickly as possible. This is just a quick look at the IMO tier system that I mentioned. This is the IMO Tier 3 SCR system, which is the scrubbers system. Essentially what it is a it's a re-exhaust of the emission gases that are coming straight off the engine. What happens with these is basically the gases are coming out, and they come out through the exhaust system through the SCR reactor, as it's known, which is basically a urea reservoir. And what that does is that then absorbs additional NOx and SOx from the exhaust gases prior to those exhaust gases being put through the turbo, which then, so essentially what you're doing is you're turbocharging the engine with cleaned gases, and then they will then go to the end of the exhaust pipe and be emitted. This is something that we're looking to roll out across the entire fleet. The new builds, or the majority of the new builds, will be IMO Tier 3 listed. The fleet that we have at the moment will be upgraded to IMO Tier 3 over the coming months and years. Just a quick overview of the vessel services that we get involved with. Obviously, the top two there, crew transfer, cargo transfer, are very self-explanatory, and which is very much the core function of the CTV offshore during its working day. We are also involved in additional elements once the packs have been dropped off. This can be anything from survey and guard operations. We have had bathymetric survey equipment mounted on side poles off the side of the CTVs, and they've undertaken bathymetric survey assistance while the packs have been on the turbines, instead of actually just idling in the field. We also get involved very regularly with foundation cleaning. This is something that we've now installed as standard on all the vessels, is a high pressure, a saltwater high pressure hose system at the bow. So once the packs have climbed, our crew can actually undertake the guano and seaweed cleaning of the boat landings, which is something which is routine and ongoing maintenance on any wind park. Refueling, again, is something, because of the large payloads, we can take a fuel up to, say, 30,000 litres. We can do some pay away fuel, And again, that's something that we've done on the temporary power solutions piece, where we've delivered marine diesel to generators that are working offshore for the construction and commissioning phase of the wind farm. ROV and drone support, something I've already mentioned, utilizing that large front deck as essentially a launch pad, as well as the crane that each of the vessels have to launch and recover ROVs into the water. Maintenance and recovery and dive support, again, fairly self-explanatory. We haven't done a huge amount of the dive support operations because divers are not regularly being used in the offshore wind sector, but the vessel definitely can be utilized for air diving operations should it so be required. On the right there, you can just see our total PAX transfers from last year. That was actually year to date end November, so that doesn't include December from last year, but we did 45,000 safe transfers with no LTI incidents recorded. And then basically you can see our PAX transfers of all time from when the company started in 2017 being just under 125,000. We are expecting that number to grow exponentially as we begin to start adding these new builds to the fleet and commencing more and more passenger transfers offshore. Quick overview as to where we've worked in Europe. As I'm sure you can see, it's a fairly extensive list of the wind parks that are in the Baltic, Germany, Denmark, Netherlands, Belgium, France, United Kingdom. And we're adding to this list continually with the contracts that we have, both on long-term and short-term operations across Northern Europe. And we are very keen to start to add to this list for areas such as Asia Pacific. We have a strong foothold there with our parent company, Purus Marine, being based in Singapore, and we're viewing that market or those markets such as South Korea, Vietnam, Japan, with real interest and with real opportunity for us to come and deliver some of the operations and skills that we've learned here in the North Sea. The vessel monitoring systems, this is something that's standard across all of our vessels. We use a system called Radar Bear Fleet. What this does is generate a DPR system or a DPR report every day, which we share with the client unedited. It shows everything from motion sickness events to impact forces at the bow on the boat landing to ensure that basically we're not exceeding the impact forces and damaging the boat landing. One of the key elements here as well, which people are really focusing on, is the fuel efficiency and CO2. We're able to incorporate the battery operations into that and actually give real-time data to the customer as to the savings that are being made as a result of the hybrid operations. But this is something clients are adopting more and more now, and stating that CTV operators have to have these systems on board or utilize the client's system to basically give real-time data as to how things are working offshore and what is going on with the vessel. This is just a quick look at the QMS standards and the quality standards that we here at HST adhere to and have to adhere to, because we are moving passengers and they are transferring over the bow, which is a complicated operation and of course involves the most important thing out there, which is obviously the human element and the human assets. As you can see, it's 4501, 1401 and 9001 for ISO. We have actually also just achieved ISO 50001, which is for the environmental impact and environmental carbon management systems. So that is another certificate that we can add to that list and will be being maintained. Just a quick view on the parent company that bought HST back in 2022. Purus Marine is made up of 4 subunits. The first is Purus Wind, which is of course where we sit, as we are supporting their CSOV operations with our CTVs. You have Purus Ferries, where again they're looking at electric ferries to do inland waterways operations in areas such as Rotterdam, Antwerp, and Amsterdam. Purus Clean Energy, which is the transportation of clean gas utilizing clean vessels to basically deliver those clean fuels to the market. And Purus Logistics, where we're looking at eco feeder vessels, ammonia carriers essentially, that are doing container transportations up and down the UK East Coast for a large port operator who's well known here in Northern Europe. I think the thing to take away from this is that the emission reduction and the innovation on vessels is something which is core to our DNA and core to the operations that we're looking to put into the market. And that is the same in every business unit within Purus. Just a quick zoom in then on Purus Wind, which obviously HST is the part of. As you can see there, the emission technology that we're working on is battery hybrid and energy saving. One thing to add to that as well is methanol. The CSAVs currently under construction will be methanol ready, as will the new Dahlman CTVs that I've already mentioned in this presentation. But this just gives an overview of basically the capabilities within Purus Wind, which are set to grow over the next 3 to 5 years. That's the end of the presentation. I hope that was informative, and if there are any questions, we would be very happy to answer the same.